Since I've joined 1 Second Before Sunrise, I've met wonderful men and women who have shown me what they and you and I can do to meet the challenges of life on this planet. On this program, come with me to Sweden to meet a determined young man who's become a leader in that country's efforts to curb acid rain. And come to China and see the dangers of chemical pesticides and what one scientist is doing to help farmers use fewer of them. Here in Sweden, I'm surrounded by people who are confronting one of the great global problems head-on: acid rain. While they are doing a lot to reduce their own sources of acid rain, they know that they can only bring about a reduction of less than 15% of the pollution that causes it. This is because most of the pollution is borne on the winds from other countries hundreds of miles away. But to effectively reduce acid rain requires a global crusade. So the people of Sweden are doing the best they can, controlling emissions, household efficiency, household conservation of energy, in the hope of persuading the rest of the world to follow their very good example.
Acid rain is one of the gravest dangers that modern industrial society creates for itself and for all living things. The source of acid rain is our demand for energy, and lots of it. The raw ingredients of acid rain are 3 chemicals: nitric oxide, nitrogen dioxide, and sulfur dioxide, which we send into the air in huge quantities when we burn fuels in our factories, power plants, and vehicles. These pollutants react with other chemicals in the air to produce acids which reach the earth as rain, snow, fog, mist, or even as dry particles. As a result of the increased acidity, fish and other aquatic creatures can't live. The tainted soil and water make it hard or even impossible for plants to grow. Once thriving lakes and rivers end up lifeless and inert. The forest canopy disappears to reveal a barren landscape. Trees and crops die because acidic soil loses the metals that plants need for food, such as calcium, magnesium, and potassium. Instead, the acidic soil makes the plant's roots absorb harmful metals like mercury and aluminum. Above the ground, sulfur dioxide eats away at leaves, stunting growth by choking the flow of water and slowing the rate of photosynthesis. Acid rain itself can contribute to global climate change. The decaying trees release carbon dioxide, and fewer trees are present to absorb carbon dioxide from the atmosphere. So the steps you take to control acid rain also pay off by reducing the risk of abrupt climate changes, which can cause massive flooding and extensive crop losses. Towns and cities, and especially the people who live in them, also face the dangers of acid rain. Buildings and statues, bridges, roads and sidewalks, pipes and aqueducts, just about anything made of metal or stone wears away when exposed to the increased acidity. And the pollutants that cause acid rain are dangerous to breathe, especially for children and older people. Precious monuments may be lost forever. We lose natural and man-made beauty. We will visit with people who in different ways are proving that it's possible to cut down on energy use, to produce energy cleanly and safely, and to thereby reduce acid rain and environmental and health problems. Johan will take us on a tour of his home, where he and his family use half the energy you would expect in a house of that size. And Johan will introduce us to Jürgen Lenz, a school teacher who lives in one of Sweden's many solar villages.
These 4 birds are new. You bought them yesterday.
But first, we'll meet Krista Ågren, a biology teacher and environmental activist who is leading Sweden's fight for clean air and an end to acid rain.
Där får han krypa lite.
When I first stood on the banks of this lovely river in the centre of Stockholm, I saw right away how deeply committed the Swedish people are to a better environment. I saw people fishing in a river in the heart of a busy industrial city and learned that they even swim in this water.
Bravo.
Bravo, bravo.
Tack så mycket.
Years ago, Krista began his campaign for clean air as a shutterbug, a teenager with a new camera and a curiosity about the mysteries of nature. A friend introduced him to a local nature group. Krista joined their fight to protect the natural beauty around them. For 20 years now, Krista has been putting together conferences and training courses where people from many countries learn what they can do to combat acid rain. For the last decade, he's worked with Sweden's Secretariat on the environment in these efforts.
Nearly all of Sweden's nearly 100,000 lakes are affected more or less by acidification. About 15,000 of them are really acidified, and a few thousand of them have become totally fishless. The fish have been killed as a result of acidification.
Krista, what exactly is acid rain?
Acid rain originally meant when the rainfall were becoming more and more acidic due to sulfur pollution. Actually, the term acid rain was invented about 100 years ago in Great Britain by a scientist called Robert Angus Smith, who analyzed the rain in the vicinity of big polluters and far away from the polluters, and they found that the closer you were the big polluters, the more acidity, the more acid the rain were. But nowadays, when we talk about acid rain, we mean a lot more than just the acid rain. Mm-hmm. We mean all kind of acid deposition, like gases, particles, rain, snow, hail, and fog, whatever. And normally we also include some other pollutants like photochemical oxidants, such as ozone.
Well, are you in Sweden getting pollution from other countries? Is it being brought on the rain, or is it just your own pollution?
Oh, no, it's being transported all over Europe or all over North America, and even between continents to some extent. That's been analyzed very carefully by big computer models, mm-hmm. And we know that for Sweden, for example, we're a so-called importing country. About 90% of all sulfur and nitrogen oxide pollution falling over Sweden is imported from other countries. On the other hand, we are also exporting some of our pollutants to other countries. So it's really an international problem.
So how does it work exactly? The pollutants go up into the what? How high up into the atmosphere?
They go up several hundred meters, even a few kilometers.
And then they're borne on the wind, or they're borne in the rain at that point?
They're borne by the winds, and when they're borne by the winds for hours and days, they will be transformed into acids, which is deposited by rain or snow over the countryside, like over these lakes and forests.
Carried as it is by the wind, acid rain pays no respect to boundaries on a map. It demands that different nations, even different states, provinces and cities get together to find solutions. In the area where Poland, Germany and the former Czechoslovakia meet, 3/4 of the forest land shows significant damage from acid rain. Who is to blame? It's safe to say that every country in Europe is. If two countries on the same continent share little else, they will always share one thing: the air. In North America, acid rain is one of Canada's chief imports from the United States and one of its main exports to the United States. Along the border between the two countries, many lakes and woodlands pay a steep tariff on this trade.
Describe to me exactly what pH is.
Well, pH is nothing you can see. It's actually a measurement of a measuring of the acidity of the water, the chemistry of the water, and you measure it in pH units. So the lower the pH, the higher the acidity. And the units goes from 0 to 14. And neutral water has a pH of 7. So if it's lower than 7, it's acid. If it's higher than 7, it's alkaline, which is the opposite of acid. So, and it's also important to remember that the pH scale is logarithmic. It means that between every point on the pH scale, between 6 and 7, for example, there's an increase in acidity of 10 times. So if you go from 7 to 6, the water is 10 times more acid. If you go from 7 to 5, it's 10 times 10 more acid, which is 100 times more acid. So it's really big changes, even if it looks very small on the pH scale.
How could you test it right here?
You can do it simply by, not very scientific, by using a pH stick. Normally you use a pH meter if you want to do it more scientifically. You can just take some water and let the stick be in the water for some time. And then it should be there a bit longer than it is now, but we're making it a fast test.
Right.
Should be a few minutes in there. And then you just test the stick and look on and read from the scale, and you find that for this lake, for example, the acidity is between 5 and 5.5.
Now, how good or bad is that for this lake?
It's bad, but it's not disastrous yet.
Would it have killed some of the life in this lake?
Surely, yes. Some of the organisms, like crayfish and some species of insects, some species of plankton, snails and mussels, for example, and also some fish species are very sensitive, and they get affected already at pH levels below 6.
So they would be completely missing from this lake?
In due time, yes. And when fish disappears, for example, when this becomes more acid, when it goes down to pH between 4 and 5, all fish will disappear in due time, in a few years. And then the whole biology of the lake will change.
By spreading lime over a lake's surface, you can raise the pH of a body of water and keep much of the mercury and aluminum out of circulation. Liming works only in the short run. If you should stop liming at any time, the metals are still there, this time in more potent concentrations.
If you could achieve the reduction in emissions that you would like to see worldwide, so that Sweden and other countries were not importing this acid rain, could things be reversed back to the way they were before acid rain began?
Yes, after some years, most of the biology will go back to normal. But then, not all the biology. It will take probably a very long time, decades or even many decades, in order to get the lakes fully recovered.
Once the people of this Swedish city learned about the dangers of air pollution, they took steps to do whatever they could to see it reduced. It turned out that ordinary citizens really can make a difference.
You promised you'd tell me a story about some housewives in Göteborg.
Yes, a few years ago there were some mothers who, when they had the information on the air pollution levels, when the air pollution levels are high, when we have inversion layers in the city, they decided they would not let their children to preschool, because if they were there, they would be out playing in the bad air. So they reported to the health insurance system that they would stay home with their children today, and they wanted their health insurance paid.
Did they pay it?
Well, they paid for one at first, but not for the other two, because legally it shouldn't work like that you can leave your children just the way you want or not. So, but anyway, they kept on struggling, and they performed a number of demonstrations. They've been looking at special polluters, especially at the traffic, and proposed a number of changes. And this has also spread to a number of other parts of the city. So just 1 year later, there were about 4 or 5 of these groups of mothers and housewives. And it's a very interesting new environmental movement showing up here in the city.
What reductions have been made?
Well, if you look at the sulfur emissions, Sweden has about halved their emissions between 1970 and 1980, and from 1980 to 87 they're halved again. But that's emission for sulfur. When we look at nitrogen oxide emissions, they've just started to decline, really.
And what have the Swedish government so far done about this?
The first introductory measures was done in the late 60s when we first learned about the acidification problem. And one started with introducing low sulfur fuel oils, and that was introduced gradually from south to north over the country. And then during the 70s one introduced a number of technical measures, cleaning up of industries, decreasing the sulfur in fuel, especially oil, even more, and also putting quite substantial energy on trying to conserve energy and trying to use energy as efficient as possible. Car emissions is getting increasingly important, and as an individual you can do a substantial impact by choosing the right sort of car when you're buying a new car.
So what car should I choose, for example?
You should find a car which is very, very fuel efficient, and you should find a car with an efficient emission cleaning system, such as a three-way catalytic converter.
I personally know very little about cars. How will I go about knowing that I've got such an efficient catalytic converter?
Well, you can ask the car dealer at first, but there are some countries where these cleaning devices are obligatory, such as the United States, some countries in Europe like Sweden and Norway, and also like Japan.
Half the oil that's burned each year is used by vehicles emitting vast amounts of nitrogen oxides. Catalytic converters, fuel-efficient engines, and better mass transportation all help reduce nitrogen oxide, carbon monoxide, and hydrocarbon emissions. When trees in Germany began dying, the prime suspect was sulfur from France's power plants. But the lichens, simple organisms that depend on air for sustenance, told a different tale. Sulfur wasn't the only culprit. Lichens were disappearing from exposure to nitrogen oxide. Cars were the main cause.
Well, I've been struck, Krista, by how incredibly clean Göteborg seems to me. How clean is it from your point of view?
Well, it seems better today than it usually is, really, because you don't see much of the pollution here, and when we have bad climate conditions like an inversion layer covering the city, we get very high concentrations of pollutants for a couple of days. So that's why the authorities and the people in the town are more and more keen on regulating traffic to get well-working public transport systems, like more trams and better transport by rail back into the city for people working in the city. They're actually developing an alarm program now where if the pollutant levels will be too high, they will close central town from car traffic. But so far, as far as I know, we don't have any ideal town. That means with a very clean air and very little private car traffic based on where the cars are based on fossil fuels. We need to get cleaner cars and less cars and better public transport.
Krista, where is the power plant you were going to show me?
Yeah, that's the one. The chimney to the right over there is a waste incineration plant where much of the heat to heat the housing of Göteborg is produced today.
And what are they burning?
They're burning waste, all kinds of waste, but just recently they installed a very efficient flue gas cleaning system, so you don't see much of the waste from the chimney anymore.
The Vartan power plant site in the centre of Stockholm serves over 100,000 homes and businesses. As well as electricity, it sends out steam for heating through an intricate web of underground pipes. Its conventional oil burners created a lot of pollution. Their new plant burns low sulfur coal, in fact a paste made of coal, water and either limestone or dolomite. The limestone and dolomite capture most of the sulfur that would otherwise escape. With this technique and with fewer moving parts, lower temperatures and less leakage, the new Vartan plant is cleaner and more efficient. Sulfur emissions are down by more than 85% and nitrogen oxides by more than 65%. Other industries are also finding ways to stem acid rain. Krista mentioned major emission reductions undertaken by Inco, International Nickel, one of the world's largest suppliers of metals. At a giant plant in Canada, Inco separates the nickel from the raw ore. This separation, called smelting, can be very dirty as it releases a great deal of sulfur dioxide. As one of the biggest polluters of sulfur gases in all of North America, Inco, urged on by the Canadian government, has been taking steps to shed itself of that dubious honour. While it has cut sulfur emissions by 70% since the mid-60s, it's now making its most dramatic move. A new oxygen-burning flash furnace captures nearly all the sulfur before it's released. By 1994, the remaining emissions will be cut by more than half, and by replacing natural gas with pure oxygen, the new furnace does something else for the environment. It no longer sends the greenhouse gas carbon dioxide into the air. These technologies that Inco employs yield more byproducts that can be recycled or resold. So even though it has spent $600 million on cleanup measures, Inco turns an even more handsome profit on its nickel operations.
If you look at sulfur, you know the sulfur content of the fuel going in.
Yes.
And you know how much fuel you burn. And then you know how much sulfur has been left through the chimney. The ones which is not left through the chimney is the ones you have caught by flue gas desulfurization, for example.
But how does flue gas desulfurization work exactly?
Well, the normal way is that you spray the flue gases containing sulfur oxides with a mixture of limestone and water. And then the sulfur will react with the lime, and you will have a gypsum formed, and the gypsum will be picked out from the flue gases later on, and that will have to be disposed of later. So by flue gas desulfurization, you can technically take away in the order of 95% of the sulfur from the flue gases. A major thing is in trying to reduce the use of energy, because the less energy we use, the less energy we have to produce, and the less pollution we will produce. So by building houses with good insulation, by using refrigerators and other electrical equipment in the houses, which is as efficient from the electricity using point of view as possible, you reduce the demand of energy, and then you also reduce pollution.
In Sweden, people now use less energy than they did 10 years ago, applying these techniques by building homes with extremely sound insulation and by using water-efficient shower heads. Johan Forsblad begins saving energy every morning when he wakes up, taking a shower or making a cup of coffee. He lives in a remarkably energy-efficient house in Karlstad.
Now, in this house, how do you heat this house?
This is distant heating through a power station, a heating station, a couple of 100 meters from here, and it heats all this part of the city, which has about, I don't know, 9,000–10,000 inhabitants.
So is this a very cheap form of heating for you?
Yes, I usually surprise my friends when I tell how much I have to pay for heating, because they think it's about the double.
Now, this is a very typical house for this area. Tell me some of the conservation features of it.
Yes, it's a mass-produced house built in 1982. Mm-hmm. It's a couple of years after the oil crisis, when it all started. You have to start to think about the price of oil and the price of energy, and also that you also started to think in Sweden that you couldn't use just one kind of energy. You have to be able to change between oil and gas and wood and coal and everything, electricity. But also we started then to build houses better, like this house has triple glass windows.
Mm-hmm. Okay.
Yeah. This is a washing machine, and it looks like an ordinary washing machine, but there are some little differences. For example, there's a separate spinner.
Yeah.
And this spinner goes, I think it's 2,400 rounds per minute. But if they were combined into one machine, it could only go 600 rounds per minute. So these clothes are much, much drier than from a combined washing machine.
Yeah.
And of course that saves energy, because you don't have to have them so long time in the dryer. Mm-hmm. And also the thermostat is much more...
It's very precise, isn't it, here? Yeah. 20,
so
30, 40.
Yeah. And of course, then you can choose exactly which temperature that's best for the clothes. And then in the dryer, also you have this thermostat with the exact. Mm-hmm. And here you can dry them.
Right.
I usually don't put on the motor, the fan. I just leave them here.
For a little bit, yeah.
It takes a night or something like that. This closet is this is our connection to the heating center, the power station. So here the pipes come from with the hot water, and then there's a meter who counts how much water we use. So we have to pay the bill according to that.
What about recycling of bottles, for example, cans, aluminium, things like that?
It's quite popular. I made an agreement with my children that they could have the money from the bottles if they bring them to the shop. And they get about 10 cents a bottle.
Are all bottles recyclable in Sweden?
No, they are not, but many of them. And the recycling bottles are going, they know about, I think they counted about 30 laps. I mean, that's
Yes.
really recycling. And the aluminum cans also have, you can get money from.
Yes.
And they are recycled, not as many times, but about more than 80% is recycling.
Ja, Ludvig och jag, vi har gjort ett avtal att vi får pengarna från här när vi pantar dem. Och Johan får pengarna när han pantar de här vinflaskorna.
Otroligt bra.
Glöm inte tidningarna.
Nej, just det, tidningarna, the papers, they are coming here to get them once a month
Otroligt bra.
for recycling.
Tack så mycket.
People in Sweden recycle as a natural way of living. 40 to 50% of all paper in Sweden is collected, and vast amounts of glass, plastic and metals. Reusing materials saves not only natural resources, but tremendous amounts of energy. Far less energy is needed to produce goods from recycled materials than from raw materials. Johan and his neighbours recycle as much as they can. The garbage that remains winds up as fuel for the local power plant. By replacing fossil fuels with refuse, the plant emits fewer pollutants. It burns 45,000 tons of garbage every year from homes, commercial buildings and industries, generating nearly 18 megawatts of electricity and co-generated steam. The hot water reaches homes and offices at temperatures ranging from 90 to 120 degrees Celsius. This is one of the cleanest garbage-to-fuel plants in the world, and it meets the extremely strict Swedish emission control standards. A simple pipe draws methane, a biogas from decaying garbage in the old landfill. This contributes another megawatt of energy to the whole electricity and heating system. In fact, 20% of energy used throughout Sweden is from garbage, wood, leaves and animal wastes, all forms of biogas.
Most of this town, I think there's more than 60,000 inhabitants, they get their hot water from a co-generated plant. And so some of the water, the hot water in this town is really heated with garbage. So when I'm standing here taking a shower, trying to wake up, you know, it is really, I'm reducing the acid rain. Even if we can't feel it, because there will be less sulfur in the air, and I will also reduce the risks of, you know, the greenhouse effect on the earth. The temperature control is, you can choose exactly what temperature you want, if it's 45 centigrades like now, or the temperature of your body, which should be 37. And then even if you are like a real Swede, you can go down to 15 centigrades, but then you need a hot towel afterwards.
What are some of the ways that not using fossil fuel that the developing countries or our countries can use and make energy?
There's a number of renewable energy sources developed and developing. What we see mostly used in many countries is various forms of wind energy and solar energy, for example, direct or indirect.
Denmark now meets more than 2% of its energy needs from wind generators on its coast. They also manufacture most of the wind generators used in the United States today. For years, it has been known that large-scale hydropower plants can cause environmental and health-related problems. Small-scale hydropower plants are a different story. They can be relatively benign environmentally and therefore offer a clean energy alternative. With Johan, we traveled to meet with Jürgen Lenz, who lives in a community outside Karlstad called Tuggelite. Today, Tuggelite is one of more than 15 communities of its kind in Sweden, relying on the renewable energy of the sun. Solar panels are providing energy to the 60 families in the village, with added power from a garbage-to-fuel plant and a methane generator.
You use very little energy here.
Yeah, we do that, and because
if you compare to other houses, how much?
About half, as usual, and we have some of ours who gets lower than that.
That means you save a lot of money living here?
Yes, and we also save our nature.
But what kind of energy do you have here then?
We have wood energy and solar energy.
But when you say that you have a burner that heats the houses, you think that it must pollute a lot?
No, it doesn't. It burns with a very high degree, and we blow in a lot of air. Therefore, we had a good burning fireplace.
It's a very efficient way of burning.
Yes, here you can see our solar collectors, and we get our warm water from it during the summer.
But the greenhouse is also an important part of the heating system here.
Yes, we warm up our air in the greenhouse first.
The greenhouse is double insulated and the roof is made of plastic tubes. The cold air is heated as it goes through the tubes and on into the house, providing a constant source of fresh air to remove indoor pollutants. Heavy window shades are used to avoid heat loss, even though the windows are triple glazed and well insulated. The houses are spaced so they don't cast shade on each other.
This uses such a little energy, and that use solar energy.
Yes, perhaps you can see it in that way, but I think we have succeeded in our house, and we use...
The largest array of solar panels in the world is in Falkenberg, on the west coast of Sweden, south of Göteborg. Stored hot water feeds into the heating system, supplying water for the whole community. Underground storage tanks can store hot water overnight and provide heated water for the cold season. In Sörö, south of Göteborg, the goal is to meet at least 60% of heating and hot water needs from the sun. The success of solar energy in Sweden gives added hope for solar's future as an energy source throughout the world. You can curb acid rain everywhere, from factory power plants down to the corner of your home. And as we have found here in Sweden, there are a lot of people who are proving that it's possible to do so.
We've shown from the environmental organizations that in order to stop the acidification going on and the forest damage going on, the deposition and the concentrations of various pollutants, especially sulfur and nitrogen and ozone, needs to be reduced by 90% over large areas. And it is technically possible to reach that if you combine the measures I mentioned: energy conservation and efficiency, technical cleaning, and a way of life where you...
10 or 20 years ago, we were troubled by the smog hanging over our largest cities. Now our concerns about the air are wider. The ozone hole, global climate change, and acid rain are threats to the entire global environment. The citizens of Sweden know that the solutions begin at home with measures that save energy and reduce pollution. In their houses, on their highways, and in their factories, they're stopping acid rain at its source.
Kan du lägga undan den lite? Titta här. Se. Det där är det. Det är samma som kryp. En liten sävsländelarv. Vill du hålla den?
Ja.
En sävslända.